been learning. Now, it's important to note that everything we have been learning, we are going to apply them in the next coming modules, because the next coming modules, it will find when we have already, configured these basic settings, and now configurations of the basic settings, it will be something like, it will be obvious. Every time anything that is we study, we must always start with the basic settings. And that's why just continue practicing on these basic settings, because it's important that we do them. So for this chapter, we'll basically identify services used in small network, identify protocols and applications used in small networks, explain how small network serves as the basis for larger networks, that is expansion or scalability. Using of ping and trace at command, we already talked about that. The host, the iOS commands we have learned, and then some troubleshooting methods and issues, and basically that's it. So there's nothing new in this particular chapter. So we are just told that, every network starts small, but it gets to grow at some point. And when it is still small network, it has very simple topology, and no firewalls, no VLANs, nothing, no routers. It only just have a wireless router, and that's what serves the purpose. Now, but networks tend to grow, from small to when now they require an IT department to maintain and troubleshoot their network, and now they employ a whole IT department. And so it is important to select your devices as growth is imminent. Cannot be prevented. It's important that when you are considering the factors for the growth of your network, check out the cost, check out the budget. What are the speeds and the types of ports that you have within your devices, or your devices will have? Are there devices you can expand, or what operating systems and features do they have? It's important. All these features, some of them we have already talked about them. We talked about subnetting. Plan your network, subnet very well, so that all the devices can be accommodated. Are you going to have end devices that are wired or wireless, or some of them you'll have to do a remote access on them? Are you going to have some servers or peripheral devices like security cameras and printers, and switches, routers, access points? So it's recommended that you need to plan, document, and maintain a very good IP addressing scheme, and that is subnetting. Because the addressing scheme that you develop initially is going to matter a lot in future, okay? Even when you need to do troubleshooting and all that. So that is very important. It's important to make a network that is redundant, so that we don't have what is called a single point of failure. Redundancy is when you have multiple links or multiple devices that serve the same purpose, so that when one goes down, the other one is still up. So single point of failure is when you only have one device in the network. When that device ever goes down, that's it. You can't survive. So redundancy is important for every network. You can see 3 servers here. When one of the servers goes down, you realize 2 of them are still functional, and they can very well serve the network. It's also important to have what is called traffic management, and this is normally done with quality of service. This is always done with quality of service. And so quality of service, remember, giving priority to some traffics like voice traffic and video traffic rather than others. High priority traffic and low priority traffic. Now, we have already talked about this protocol. I don't need to repeat so much about them. We talk about SSH for remote access, HTTP for exchange of text, graphics, pictures, videos, SMTP, POP for post office protocol. And these ones are basically for email. These ones are used for email. And so POP, IMAP, and SMTP simple mail transfer protocol, post office protocol version 3, and the internet access protocol, file transfer protocols, and even the secure or security file transfer protocols used for secure downloading and uploading of files from and to the FTP server. Assignment of IP addresses, DHCP, the main host the dynamic host configuration protocol, used for leasing IP addresses, to end devices. DNS is domain name service. So DNS is, for resolving domain names to IP addresses and vice versa. So it's important. These ones are very mandatory protocols that must be in every network. For advanced networks that want to manage both voice and video traffic, they must have good infrastructure to serve that purpose. Of course, voice over IP, they must have the IP telephony configured in their devices, and they must have the RTA protocol, the real-time applications like the RTCP, real-time transport control protocol, and the real-time streaming protocol. So these are, again, protocols for managing voice and video traffic for organizations that manage a lot of video and data. As the networks grow, make sure you expand your network documentation, get your physical and logical topologies well. Device inventory, the list of all the devices, routers, switches, servers, laptops, desktop computers, IP phones, with their operating systems, with their IP addresses, whether static or dynamic, with their versions and all that. Growth also requires you to have a good budget, like we have already said. Checking on a financial year. Check on your traffic analysis. What are the points of the network that uses so much bandwidth? Is it the VLAN or the network for the students in a university, for example? Which applications that require so much bandwidth? So check on your traffic analysis and how much bandwidth that will dictate for your network. We already talked about verification of connectivity. Here we use ping for sending echo requests and echo replies. These ones are ICMP protocols, Internet Control Message Protocol. And it's always ping, which sends an echo request and returns an echo reply. The sister of ping, of course, is traceroute, and we can also do what is called an extended ping. For an extended ping, this is normally done within a router, not a PC. The normal ping, you can do it within a PC, but for the extended ping, you type ping on the router, privilege exec mode. You don't put any IP address, you press enter, then it provides you where to put the target IP address. Keep on pressing enter. When you reaches extended command, you put yes there. Why? You put the source address. So extended ping actually enables you to ping from a certain IP to a certain IP. So from a specific source to a specific destination. So that is what is meant by extended ping. So I mean, most people don't always use it, but it's also available. I mean, it's also available, basically to be known that. TraceAt is the other sister for ping, and we did talk about TraceAt extensively. You can use the word TraceAt, the command TraceAt in a PC, but within a router, you use traceroute. You use trace, and you can see down here is the traceroute command and TraceAt. It's in a PC. Same command, different names according to where you're using it, but it does the same thing. It also has the extended trace route where you can be able to trace from a specific source to a specific destination. All right. So just different variations within the trace route and the ping. But most people do not normally venture so much into the extended versions of either ping or trace route, but it is available as well. Network baseline, very important. For network baseline, basically is the normal operations of the network when the performance is, is at optimum. How does the network perform when everything is at optimum? Very, very important. And so that is always very, very important. How does the network perform when everything else is optimum? Why do you need to know when the network performs so normally, okay, or optimally? You need to know that because that's how you're able to gauge when problem within your network. Okay, so that wherever there's a variation, you can always compare it with the baseline, and that's how you know that you can actually be able to do that. And there are softwares, by the way, there are softwares that are used for knowing the network baseline and keeping that information and use it wherever is it that there's a problem. We have, of course, these commands, we have used them, commands like ipconfig /all. There's a difference between ipconfig /all and ipconfig. When you use ipconfig, there's one more important thing you cannot see with ipconfig. You cannot see the MAC address when you use ipconfig. But when you use ipconfig /all, now you'll be able to see the MAC address, which is normally called the physical address. There's another version of ipconfig called ipconfig /release and /renew. When two devices have acquired the same IP address, okay, two PCs have acquired the same IP address from the same DHCP server, it is possible. You need to go to both PCs and you do ipconfig /release. Okay, you release it and then you renew afresh. Okay, or when a device acquires a wrong IP address, you just need to say ipconfig space /release, then you do /renew, and you'll be good to go. Okay. For any DNS entries that your PC has already captured, that means the DNS resolutions that your PC has done, you can always do ipconfig space /display DNS, and that will display that particular record to you on your Windows computer. Of course, some of you use Linux operating system, where in Linux, instead of saying ipconfig, we say ifconfig, where if means interface, config, if means interface. But the most common one nowadays is IP address. You just say IP address. It's a command that works just like ifconfig. When you say IP address with a space between IP and address, that is used to display the addresses and their properties. And that is that. So it's important that you need to also venture into not just Windows operating system. You need to learn other operating system like Linux. Linux is a very powerful. I have not once, not twice displayed for you some of my Linux virtual machines here. And it's an amazing thing knowing how to use the Linux operating system. So please challenge yourself, install some virtual machine and learn another operating. It's like learning another language, not just knowing English, Kiswahili, and your mother tongue. It's not very good. So learn. Our mother tongue for a long time has been Windows. So let's get out of Windows and let's learn another operating system. We've learned of this command. To view the ARP table on your PC, you say ARP space space -a to be able to do what? To display the ARP table or the ARP table, which basically stores IP and MAC address bindings there. Okay. So it's important again to do that. But you can always, of course, clear that table. You just say net SSH, net SH, interface IP, delete ARP cache. But I think there's a shorter version of that. We just say ARP space -d for delete, and you'll still be able to delete the ARP cache. All right. So that is for the ARP command. Very, very important. Of course, we have been talking about some of these commands. To view the running configuration file, just say show running -config. For your information, all show commands must be put at the privilege exec mode. All show commands must be put at the privilege exec mode. So show running config, show interfaces, which verifies the status of all your interfaces. Show IP interface. It verifies layer 3 information of the interface or IP status of that interface. Show ARP, of course, for the router will view the ARP table with a router. Show IP route, the routing table, IP routing table of your router. Show protocols. This one will display the protocols that are currently operating in your device. Show version is a very powerful command, guys, and this will come to exam. We say show version, it verifies not just the memory, the interfaces, any licenses that your device might have, any types of memories there. So that's why the show version command is a bit powerful. Show command is a bit powerful. So we have the show. We have other commands like show CDP neighbors. Of course, we will talk about CDP, which means Cisco Discovery Protocol. And the Cisco Discovery Protocol, this is a protocol that is mostly used to learn about the details of other Cisco devices within the network. So it can discover so many things about other devices, so long as they're in the same network. It can identify what devices, is it a switch or router? What IP addresses do they have? What port are they connected to within our network? What is the capability? Is it layer 2 or layer 3 device? And what platform or what is the license or the version of the operating system? So show CDP neighbors. There's also the command show CDP neighbors detail. If you just say show CDP neighbors, you'll see so many things, excluding one thing, IP addresses. So when you want to see the IP address of all the other Cisco devices, you must say show CDP neighbors detail. Show IP interface brief, show IPv6 interface brief. These commands, use them to view the brief listing of all your interfaces, the summary of your interfaces right there. For the sake of troubleshooting, we have 6 standard troubleshooting steps. First, you must identify the problem. Once you identify the problem, then you need to develop a question or what's called a theory of a probable cause. Okay. So once you get a theory, what must have been some questions, I mean, that might lead to what the problem was. But so once you have that theory or theorem, you need to test it. So test the theory to determine the cause. Then once you test it and it's working, now get a plan of action and implement the solution according to that theory. Verify that the solution is correct, is working. And if there are any preventive measures, you need to implement them. And finally, you need to document all those findings, actions, and outcomes. Note them somewhere so that the next time the same problem occurs, you don't have to waste so much time. It can always be just resolved. So this is this is the 6 troubleshooting steps, and we will be learning this, I think, in the final module, the 3rd module. We will now extensively talk about the troubleshooting, and we'll expand these troubleshooting approaches. So sometimes you're able to solve a problem, but sometimes you need to take it to your senior. So it means you need to escalate the problem to the senior most person, the person to whom you answer, so that with their level of experience, they can be able to know what you don't know. So if you can't resolve, then you're gonna need to escalate it. We have this called debugging, which basically is another command which displays real-time analysis of different event messages of the operating system, protocols running within your device, and any mechanisms there. So debugging is a very, very serious protocol, and if you enable it on your device, it's said it should never be enabled during the production hours of your network. Enable it when there's not so much traffic, because it can interfere with the functionality of your device, because it now displays on the command line, displays real-time movement of the files and packets within your device. So it's important. How do you enable it? Just say debug. When you say debug, it will start, of course, debugging them, revealing them. But when you want to stop them, you just say undebug all. Undebug all. Undebug all. We stop all the debugging. Yeah, I think for duplex, of course, we talked about duplex and issues with duplex because they can also cause problems normally. You know, we have full duplex and we have half duplex. Full duplex, device can send and receive traffic. Half duplex, a device can only do one thing. It can only send or receive, but not both simultaneously. All right. So both ends must always have the same duplex if you want to be on the safer end. So these are also things that can cause, you know, the mismatch of both of them, either the duplex or even speed. They can cause connectivity problems within your network. IP address issues, make sure that you do good subnetting. Make sure that you assign correct IP addresses to interfaces. These are good troubleshooting. And use commands like show IP interface brief to give a summary or a brief listing of your IP address assignments. Yeah, because this can save you a great deal so that you check that IP addresses configured are actually well done. I, of course, talk to you about a PIPA, automatic private IP addressing. And I told you anytime a device assigns itself an IPv4 address that begins with 169.254.anything.anything, that's a problem, and you need to sort that. But when this happens, this is the time you need to go and say ipconfig/release and then renew, because sometimes your device could not just locate the DHCP server, but it's now back on the network. So it's important. It's important that this need to be paid attention to. Yeah. So the device should never have such an IP beginning with 169. Okay. But operating system like Linux, by the way, and the Mac or X, they don't use a PIPA. It's important to know that this is only for Windows machines. Okay. It's important also to check the default gateway. This can be a very common cause of network having issues if the device cannot be able to have the correct default gateway IP address. So check on that using ipconfig. Maybe it was configured on the DHCP server only. So you should also be able to check that. DNS, very, very crucial for troubleshooting our networks. Make sure that your DNS is active within the network and the devices can be able to correctly identify the DNS server. And NS lookup is a very powerful tool to test if the DNS is working on your PC, because you can always use that to manually query the DNS server within your network. If you can't get responses, then that's how you know the DNS has an issue. Now, there's a whole packet tracer here, which is found at the end of the network. I actually want to open it for you guys so that we can be able to see. So there's an activity that I'll give you for homework here. And there's what is called the skills integration challenge. This is the first assignment. Please, I want you guys to note on page 1782 and 1783. Please do note that and put it in the group. 1782 and 1783. These are skills integration challenges. If I open 1782, it's going to open in a few. It's a skills integration challenge, and it's a packet tracer that is going to let you to implement everything that we have learned from the beginning to date. And it's going to look like this. Let's just open and see what is happening here. Correct. So this is the diagram, the topology, and these are the instructions. So what I guess you're going to do, there's going to be some subnetting here. If you see an address provided here and you already see 100 hosts, 50 hosts, 25 hosts, then that's how we know there's some subnetting here. We're going to subnet and configure this network. IPv6 addresses, I think, have been provided on the table. And you're only going to configure and get IPv4 addresses here and configure the basic settings, including SSH is here. I can configure for you this SSH very fast so that you can see what's actually happening here. Let me just get into the router and show you basically how to do this, how you're going to work on this. So you'll do subnetting. We have talked about that before. I'm only going to configure the part that is there for security. So we are told I do enable, I do conf t, and say the host name is R1. And I'm told to set the domain name to ccna-lab.com. Very, very, very easy. Say IP domain -name CCNA. You must put it the same way it is. CCNA small letters lab.com. Don't put your capital when you're told put small. Generate 1024 keys. Crypto key. Generate RSA. Can press enter here. If I have not remembered the full command, 1024. Then I told configure virtual lines for SSH. I say line VTY 0 to 15 maybe. I say transport input SSH. I say login local. You realize I'm not following the order here because it's not important. Then I'm told to use the local usernames, use the local user profiles for authentication. So I'm told to create one of my own. I'll just say username. Okay, let me see if there are any local usernames here. I think they must have given them to me at some point. As the console portal. I'm trying to check if they're here. Or maybe they have them already configured. I don't know. Oh, yeah. Right here. They are given here. Sorry. They're saying that we have already said login local. So they just create a username admin1 here. You say username admin1. Privilege is 15. You can see that. Privilege is 15. Password is admin1 per 55. Say secret admin1 per 55. Enter. At this point, they will not tell you, but they'll configure IP SSH. I want you to get used to version 2. Then they have told me something very interesting here. Configure the console and virtual lines to log out after every 5 minutes of inactivity. Line VTY 0 space 4. Let me say 0 15. Is to log in after every 5 minutes of inactivity. Is a exec -timeout. When I put shift and question mark, it wants minutes. They say 5 minutes of inactivity. Enter. I also say line. They say console also line. Console 0. Exec -timeout 5. And then they want me to do something more here. We had learned about that. They say block anyone for 3 minutes. So remember that command. Login block -4. Login block -4. Block anyone for 3 minutes. You must change 3 minutes to seconds. That's 180. Okay. 3 minutes. Who first log in after 4 attempts? You say attempts 4. Who first log in after 4 attempts? within 2-minute period. So we say within 2 minutes, within 2 minutes. And 2 minutes, it's 120 seconds. That is it. So login, block hyphen for 3 minutes, that's 180 seconds. Attempts are 4 attempts. First login within 2 minutes, 120 seconds. And you're good to go. So those are some of the things you people are going to configure for this work here. So please work on that and see if you can be able to challenge yourself. You realize that small configuration, I already got 13 points here, but I want you to go and make sure you get to 100%. So that is 2 assignments. One is 1782 and there was 1783. But before you go to those two, I'm gonna need you to do this design. Okay, this is a skills practice. Design and build a small business network. Let's see what is here. So you're going to design and build a small business network, and let's just see that open here. You already have gadgets here. You're given a few instructions here, but most of them are going to be your own innovation. Devices are given here. The table is here. The laptops and the desktop computers are also here. The voice over IP phone, the switches and routers are here. The cables are here. The rack is actually here. Okay, so you're going to design from your own innovation. You're going to design that on 1781. 1781. Now, of course, I'm going to need you to for chapter 16. I will need you to work on 1646 so that you start learning configuring SSH. 1646, it's important, and 1651, 1646 and 1651, 1646 and 1651. Those are the assignments that we have today. Otherwise, I think for CCNA, for CCNA 1, that is the last chapter for CCNA 1. And after this, we'll be moving to CCNA 2. But we need to make some decisions before you guys go. You'll make the decisions, and Leonida will communicate in the group. Now,